All right, welcome everyone. Listen up. If you're getting ready for your GCSE computer science exam, this is for you. We are going to break down the absolute rock-solid fundamentals of programming. The essential building blocks that make every single app, game, and website actually work. So, let's dive right in. Okay, let's kick things off with a pretty big question. Have you ever really thought about it? When you're playing a game, how does it keep track of your score, or your username, or how many lives you've got left? How does a computer program actually remember anything at all? Well, the answer all comes down to three core ideas: variables, constants, and operators. These are the basic tools a program uses to hang on to information and then, actually do stuff with it. Getting these down is the first giant leap to thinking like a real programmer. All right, first up, let's tackle the most important of these building blocks: variables. The easiest way to picture a variable is just to think of it like a labeled box inside the computer's memory. It's a place where you can pop a piece of information that you know you're going to need again later on. Now, for your exam, this definition is key. A variable is a named memory location that stores a value. But here's its superpower, and this is the crucial part. That value can be changed. The stuff inside the box isn't stuck there with superglue. It can be updated, swapped out, and changed around while your program is running. Okay, here's something you really need to know. When we talk about variables, you're going to see code written in two different styles. First, you've got pseudocode. Think of this like a rough sketch. It's for planning out the logic without getting bogged down in perfect grammar. And then you've got Python, which is the real deal, an actual language the computer can understand and run. You've got to be comfortable with both. And here we see assignment happening. Notice how both of them use the equal sign? Now this is super important. That equal sign isn't asking a question, it's giving a command. It's saying, hey computer, take the thing on the right and stuff it into the box labeled on the left. So the variable name gets the value Bob, and the variable spam gets the number 5. Simple as that.
Now, you can't just call a variable whatever you want in Python. Oh no. There are some hard and fast rules you've got to follow. It must be one single word, you can only use letters, numbers, and the underscore character, and it can never, ever start with a number. And here's a big one that catches people out. Names are case sensitive. A variable called spam in all lowercase is a completely different thing from spam in all caps. The computer sees them as two separate boxes.
So that's variables, values that can change. But what about the opposite? What about values that you need to stay the same no matter what? Things like, say, the value of VAT, or the number of days in a week. Well, for that, we use something called a constant. And this brings us to another one of those key differences you need to know. In pseudocode, you can literally write the word const, and that tells the computer, hey, enforce this rule, don't let this value change. Python, though, it's a little different. It works on a trust system. There's no special const word. Instead, we have a convention, an agreement between programmers. We write the variable name in all capital letters. That's our signal to everyone else reading the code that says, hey, this value is meant to be fixed. Please don't change. All right, so we've got our storage sorted with variables and constants. But just storing stuff is kind of boring, right? How do we actually, do things with the data? Well, that's where operators come in. These are the symbols that let us do calculations, ask questions, and make things happen. So first up are the ones you probably already know and love from maths class. Arithmetic operators are your basic tools for doing all sorts of calculations. Of course, you recognize plus, minus, multiply, and divide. No problem there. But these next three, these are classic exam topics, so you'll want to pay close attention. The double slash, that's for quotient, or div. It just gives you the whole number part of a division, so 9 divided by 2 is 4. The percent sign, percent, is modulus, or mod. It does the opposite. It gives you just the remainder. So 4 divided by 3 has a remainder of 1. And finally, the double star, is for exponents, to the power of. Okay, moving on from math, our next set of operators are all about asking questions. Comparison operators take two values, compare them, and then spit back a simple answer, either true or false. So here we've got all the usual suspects: not equal to, less than, greater than, and so on. But look, if you remember one thing from this section, make it this one at the top. The single most common mistake beginners make is mixing up the equal signs. Remember this forever. A single equals is for assignment. It's for putting a value in a box. A double equals is for comparison. It's for asking, hey, are these two things the same? Okay, but what if your question is a bit more complicated? What if you need to check if two things are true at the same time, or maybe if just one of them is true? For that, we need our final group, logical operators. Think of the AND operator as being really strict. For the whole expression A and B to be true, both A and B have to be true. If even one of them is false, the whole thing just gives up and says false. Then you've got OR, which is way more chilled out. For A or B to come back as true, you just need at least one of them to be true. The only possible way for OR to be false is if both A and B are totally false. And rounding things out is not. This one's super simple. It just flips whatever you give it. So not true becomes false and not false becomes true. It just inverts the value. All right, deep breath. We've looked at variables, we've looked at constants, and we've covered 3 different types of operators. Now, let's put it all together and see how they actually work in a sequence of real code. Because that's all programming really is. Just a list of instructions followed one after the other. Okay, let's follow the computer's thinking line by line. First thing that happens, a variable called spam is created, and the value 2 is put inside it. Done. Next line, another variable called eggs is created, and it also gets the value 2. Now watch this part closely. The computer looks at spam equals spam plus eggs. It always works out the right side first. It says, okay, what's in spam right now? It's 2. What's in eggs? Also 2. What's 2 plus 2? It's 4. Then it takes that answer, 4, and assigns it back into spam, completely replacing the old value. So when we finally print spam, the value that comes out is 4. And that right there, that is the concept of sequence in a nutshell. A variable's value isn't permanent. It all depends on which line of code the computer is looking at right at that very moment. It's a step-by-step process. And the state of your program, the values inside all your variable boxes, is constantly changing as it runs. And honestly, that's the secret sauce. Storing data in variables, locking down data with constants, and then using operators to mash it all together and make things happen. If you can really get your head around these 3 fundamental ideas, you've pretty much cracked the code on how almost all programming logic works. So, there you have it. You've got the tools. You understand the basic grammar for talking to a computer. The only question left is, what problem are you going to solve first?